Chapter 9, Question 10. We've got Bert and Ernie. Bert has a deck of cards well shuffled, 52 of them. Ernie is throwing a die that is 12-sided die, so we'll have to remember that. And then we want to see a bunch of combined probabilities. Hopefully you'll see that the deck of cards and the rolling of the die are independent events. One does not affect the other. So again, we use the multiplication principle. So for the A question, we are being asked what's the probability that from the deck of cards a jack is drawn, and that from the die, the probability that we roll the number 5. Okay. Again, we do the counting. How many jacks are in a deck of cards? There are 4 out of 52. How many 5s are on a 12-sided die? There is 1 out of 12. And we reduce the 4/52 down to 1/13 times 1/12. And when we multiply this together, 1 times 1 is 1. 13 times 12 is 156. Now, since there's going to be several problems, or 7 ones, I'm going to leave myself some room. I'll leave it up to you to go ahead and calculate that percentage if you like. The B question is going to now consider the probability of getting a heart and the probability of rolling a number less than 6. So we have how many hearts in a stack of cards? There are 13 in each suit, so there are 13 hearts out of 52 cards. How many numbers are less than 6 on a 12-sided die? Well, there's 5. 1, 2, 3, 4, 5 out of 12. Okay. We can reduce the 13 out of 52. 13 goes into both of these numbers, so that reduces down to 1/4. 52 divided by 13 is 4. 5/12 does not reduce, so we leave that as is. And then just multiply the two. 1 times 5 is 5, and 4 times 12 is 48. And that's in reduced form. The C question is asking us what's the probability of getting a face card, and what's the probability of getting an even number on the die. Okay. Face cards, there's 3 in each suit. Jack, Queen, King. 3 times 4 is 12, so 12 out of 52 in the card deck. Even numbers on a 12-sided die, 2, 4, 6, 8, 10, 12. There are 6 even numbers out of 12 total numbers. We can do the reducing because, let's see, what is it? 3 goes into both of these. 4 actually goes into 12. 4 goes into 52. So 12/52, dividing both of them by 4. 12 divided by 4 is 3. 52 divided by 4 is 13. Now 6 and 12, 6 goes into both of those. So 6 divided by 6 is 1. 12 divided by 6 is 2. And now we just continue multiplying. 3 times 1 is 3. 13 times 2 is 26. Again, turn it to a decimal and a percent if you would prefer, and that'll give you a feel for where we're at. But these will allow you to check the answers. D, we want to know the probability of getting a red card times the probability of getting a 15. Now, okay, yes, there is not a 15 on a 12-sided die. There's no room for it. So that's a 0% probability. If one thing is a 0% probability, there is no chance of this thing happening. So we could just say it's 0. But let's walk through it and you'll see we'll end up with 0. Okay, probability of a red. Well, there are 2 suits that are red, diamonds and hearts. So 13 and 13, that's 26 out of 52. There are 0 15s on a 12-sided die, 0 out of 12, that's where we get that. 26 out of 52 reduces down to 1/2. 0 out of 12 reduces down to 0. And 1/2 times 0 is 0. Finally, the E part, the probability of not getting a jack and the probability of not getting a 12. So So again, we could do this like we did in the last chapter with 1 minus the probability of getting a jack and 1 minus the probability of getting a 12. Or we can also just sort of do the counting and just go straight away. So there are 4 jacks in a 52 deck of cards. So let's just do it up ahead. Let's take those 4 out. How many are left? There's 48. So any of these 48 cards would work. So 48 out of 52 are not jacks. How many sides on a 12-sided die are not a 12? Well, there's 11, 1 through 11. So there's 11 out of 12. So that's maybe a little more forward, I think, a way of thinking. Now, both, at least the 48 out of 52 can reduce because, let's see what goes into both of these. 4 goes into both of these. So 48 divided by 4 is 12. 52 divided by 4 is 13. And then we're going to multiply by 11 over 12. And then what we get to do is in this multiplication, 12, before we just multiply out, you can take 12 divided by 12, so these two will cancel each other out, becoming 1. So 1 times 11 is 11, 13 times 1 is 13. So 11/13 is our probability. You'll see that's about an 84.6% chance of happening that we don't get a jack and don't get a 12.